So we continue. So now we have seen that the length of these, the length of this squared is equals to the sum of these two. Therefore, this triangle is a right-angled triangle. At what? We look at this part here, where which one is common here is C. So it's right-angled at C. So here you're going to have something like this. You have this is a triangle. So now that is our hypotenuse. So that is our hypotenuse. So it is our A. So now we can say this is A, that is B. And then this is C, because that is the length there. That length is the one, the square of that length is equals to the sum of these two, the sum of squares of these two lengths. Yeah. So that's how our diagram is going to be. So you are seeing that it's centered, it's right angled at C. That's why we are seeing that it's also common here. C is common. So you can so now it's up to you. You can either go this way or you can go the vector way. The answer will still be the same. So we are done with that part. Now let's look at the next part. Let's look at the next part. So the next part is requiring us to find the perimeter of that triangle. So now it's going back in here. So now you have this is a triangle. Okay. Let me just write the answers on top because I'll need them sometime. So I have modulus of AB, vector AB squared, which is equals to 625. The modulus of BC squared is equals to 225. And modulus of CA vector is equals to 400. So I have those values there. You can now wrap this piece so that I use it. So guys, you have this is a triangle. You have triangle A. It's supposed to be triangle C. A, like that. So you have that triangle, and then you are asked to find the perimeter of this. So I mean that the perimeter of this is just the sum of all these. The sum of all. So now from here you can either use that. You can either use that to find the length here. So what is if modulus of AB squared is equals to 625? What about just AB itself? What about just modulus of AB, the distance AB? Just the root of 625. So to find the length of all these, just square root all the three values. So to find the distance here, the distance between A and B, you just square root that answer there. You square on both sides so that you get rid of the square there. You square root on both sides to get rid of the square. So what is the square root of that is 25. 25. And then we move to 225. What is the square root of 225? We get it. We have 15. So 225 is BC. BC is 15. And then CA is 20. So you have all the sides. So the perimeter is just a matter of adding this plus that. So perimeter is equals to BC plus CA plus AB, which is equals to 15 plus 20 plus 25. So we have 45 here, 60. So this is 60 centimeters. So we found that our perimeter is 60 centimeters. Or we can use vectors. We can use vectors where we have to find, for example, the way these vectors are. AB vector plus BC vector plus CA vector. This is giving us the perimeter. So our AB here, so you can just add it's not going to be BC, this plus this plus this. Let's give it a try. Never tried this way. But let's just do this. So perimeter here, you can just say modulus of this plus modulus of this plus modulus of that. So the modulus of this is what you found there. The modulus of this is already 6 to 5. No, the root of 6 to 5, which is 25, plus the modulus of BC is 15. The modulus of AC is 20. It's giving us centimeters. So now we have found the perimeter for that triangle. Unless there's a question, before we look at the last part, before we look at the area of the triangle. Any question on the perimeter? Okay. Since we don't have questions, let's look at the area of the same triangle. So now, guys, to find the area of a triangle in vectors. So area of a triangle in vectors. Area of a triangle in vectors. Area of a triangle in vector is just given by A, which is equals to 1 over 2, the modulus of the dot product of either BC times the dot product BC times C A vectors. So that's the formula when you're using vectors. So the formula for area of a triangle is given by that. So what is inside there is the dot products. It doesn't necessarily mean that you always have to use this and this, that and that. No, you can pick any, but this is what we have. You just have to pick two. Yes. So let's find what BC times CA is. Just a minute. So it doesn't mean that it's always when you're supposed to use that. You can either use even A, B, B, C. You can also use even this 1 over 2 AB times B, C vector. Sure. Just write it on top. So area is equals to 1 over 2 AB vector times BC vector. Like that. So we'll start with AB, the dot product, times BC vector. This is equal to determinant. So we have, so now our BC, so look at our vector B, is in how many dimensions? Is in 3 dimensions, X, Y, Z. So you can say this is the I component, J component, and the K component. So we'll say I, J, and K. Where our I here, we start with AB. AB, our I is negative 25, and our J is 0, and 0 there. And then BC, our I is 9, 0, and 12, like that. Oh, sorry, determinant. So next, we start with I. So here, for this, you remove that. Remove that to find. So we are going to remain with this part here. So it is 0 times 12 minus that. So this part is giving us a 0. Then minus j, we do the same. So now we are here. So we have to remove that and also remove that first part. So we are going to remain with this area and that area there. So negative 25 times 12. So negative 25 times 12. This is giving us negative 300. Negative 25 times 12, 300, and then 1 minus 0 is 0. So it will just give us this. Then in last, we delete k, and then that part. So I'm going to remain with this part. So it is plus k. So we have 25 minus 0, so it will just give us a 0 there. So we'll remain with me. 0I minus, is plus 300 j plus 0k. So now we find the modulus. So the modulus now, the modulus of A, the dot product, see here, is equals to the root. We have these components, we have 0, 300, 0. So 0 squared plus 300 squared plus 0 squared. So this is going to give us 0 plus 3. So we're just going to find that it's 300. So squared and root cancels. We're going to remain with just 300. So we found that part there. So that part there is 300. So the area will be 300 divided by 2. So the area is 300 divided by 2. So therefore, just write it here. Therefore, area is just equals to, we found that piece there, the dot product, which is this 300. 300 over 2, which is 150. 150 units, square units. So we found the area of that triangle. Any question? Before we do it in an alternative way. Okay, so now guys, the area there is 150 square units. So let's try to find the area in an alternative way, the way we used to do it at school. Remember in grade 12, where you are given a right angle like this, and then they ask you to find the area of the right angle. You say the area of the right angle is equals to what? Half BH, isn't it? The area is equals to half BH. If at all it's a right angle, but if at all it's not a right angle, that's why I use the sine rule. But here you can't use sine rule because it's a right angle. So let's try to use the one that we are familiar with, the one that we've been using at grade 12. So I can just remove this. And rub this part here. And then I'll write it. I'll say alternatively, area of a right angle is 1/2 times BH. Half. What is our B? The base there is 20. 20 times. What is our H? Our height is 15. So 2 into 2 into 20 is 10. So 10 times 15, that's 150 unity. So you have seen the alternative way has given us 150. The vector way has also given us 150. Unless there's a question. I'm sure for today we'll just end there. Any questions, guys? Any question?